The mysterious force. What exactly is the mysterious force we call electricity? It is simply moving electrons. And what exactly are electrons? They are tiny particles found in atoms. Everything in the universe is made of atoms. Every star, every tree, every animal. The human body is made of atoms. Air and water are, too. Atoms are the building blocks of the universe. There are over 100 different types of atoms found in the world around us that make up elements. Each element is identified and organized into the periodic table. Atoms of these elements are so small that millions of them would fit on the head of a pin. Atoms are made of even smaller particles. The center of an atom is called the nucleus. It is made of particles called protons and neutrons. The protons and neutrons are very small, but electrons are much, much smaller. Electrons spin around the nucleus in energy levels a great distance from the nucleus. If the nucleus were the size of a tennis ball, the atom would be several kilometers in diameter. Atoms are mostly empty space. If you could see an atom, it would look a little like a tiny center of spheres surrounded by giant invisible clouds. The electrons would be on the surface of the clouds, constantly spinning and moving to stay as far away from each other as possible on their energy levels. Electrons are held in their levels by an electrical force. The protons and electrons of an atom are attracted to each other. They both carry an electric charge. An electric charge is a force within the particle. Protons have a positive charge plus and electrons have a negative charge minus. The positive charge of the protons is equal to the negative charge of the electrons. Opposite charges attract each other. When an atom is in balance, it has an equal number of protons and electrons. Neutrons carry no charge, and their number can vary. The number of protons in an atom determines the kind of atom, or element, it is. An element is a substance in which all of the atoms are identical. An atom of hydrogen, for example, has one proton and one electron, and almost always no neutrons. Every stable atom of carbon has 6 protons, 6 electrons, and typically 6 neutrons. The number of protons is also called the atomic number. The atomic number is used to identify an element. In most objects, the molecules that make up the substance have atoms with electrons that spin in random directions. They are scattered evenly throughout the object. Magnets are different. They are made of molecules that have north and south seeking poles. The molecules in a magnet are arranged so that most of the north-seeking poles point in one direction and most of the south-seeking poles point in the other. Spinning electrons create small magnetic fields and act like microscopic magnets or micromagnets. In most objects, the electrons located around the nucleus of the atoms spin in random directions throughout the object. This means the micromagnets all point in random directions, canceling out their magnetic fields. Magnets can produce electricity. We can use magnets to make electricity. A magnetic field can move electrons. Some metals, like copper, have electrons that are loosely held. They are easily pushed from their levels. Magnetism and electricity are related. Magnets can create electricity and electricity can produce magnetic fields. Every time a magnetic field changes, an electric field is created. Every time an electric field changes, a magnetic field is created. Magnetism and electricity are always linked together. You can't have one without the other. This phenomenon is called electromagnetism. Power plants use huge turbine generators to make the electricity that we use in our homes and businesses. Power plants use many fuels to spin turbines. They can burn coal, oil, or natural gas to make steam to spin turbines. Or they can split uranium atoms to heat water into steam. They can also use the power of rushing water from a dam or the energy in the wind to spin the turbine. The turbine is attached to a shaft in the generator. Inside the generator are magnets and coils of copper wire. The magnets and coils can be designed in 2 ways. The turbine can spin the magnets inside the coils or can spin coils inside the magnets. Either way, the electrons are pushed from one copper atom to another by the moving magnetic field. Batteries produce electricity. A battery produces electricity using two different metals in a chemical solution. A chemical reaction between the metals and the chemicals frees more electrons in one metal than in the other. One end of the battery is attached to one of the metals, the other end is attached to the other metal. The end that frees more electrons develops a positive charge, and the other end develops a negative charge because it attracts the free, negatively charged electrons. If a wire is attached from one end of the battery to the other, electrons flow through the wire to balance the electrical charge. A load is a device that does work or performs a job. If a load such as a light bulb is placed along the wire, the electricity can do work as it flows through the wire. In the electric circuits diagram, electrons flow from the negative end of the battery through the wire to the light bulb. The electricity flows through the wire in the light bulb and back to the battery. Electricity travels in circuits. Electricity travels in closed loops, or circuits. It must have a complete path before the electrons can move. If a circuit is open, the electrons cannot flow. When we flip on a light switch, we close a circuit. The electricity flows from the electric wire through the light and back into the wire. When we flip the switch off, we open the circuit. No electricity flows to the light. When we turn on the TV, electricity flows through wires inside the set, producing pictures and sound. Sometimes electricity runs motors and washers or mixers. Electricity does a lot of work for us. We use it many times each day. Recently, there has been more interest in using electricity to help reduce the amount of petroleum consumed by the transportation sector. The plug-in hybrid electric vehicle PHEV and the dedicated or battery electric vehicle EV are available to consumers in the open market. Many car manufacturers are offering PHEVs and EVs in more models. As the diagram to the left shows, electric vehicles store electricity in large battery banks. They are plugged into a wall outlet either at 240 volt or standard 120 volt for several hours to charge. An electric motor powers the wheels and acts as a generator when the brakes are applied, recharging the battery. Electricity is different from primary sources of energy. Unlike coal, petroleum, or solar energy, electricity is a secondary source of energy. That means we must use other energy sources to make electricity. It also means we can't classify electricity as renewable or non-renewable. Coal and natural gas, which are non-renewable, can be used to make electricity. So can hydropower, a renewable energy source. The energy source we use can be renewable or non-renewable, but electricity is neither. We use more electricity every year. One reason we use so much electricity is that it's easy to move from one place to another. It can be made at a power plant and move long distances before it is used. There is also a standard system in place so that all of our machines and appliances can operate on electricity. Electricity makes our lives simpler and easier. Let's follow the path of electricity from a power plant to a light bulb in your home. First, the electricity is generated at a power plant. It travels through a wire to a transformer that steps up, or increases, the voltage. Power plants step up the voltage because less electricity is lost along the power lines when it is at a higher voltage. The electricity is then sent to a nationwide network of transmission lines. This is called the electric grid. Transmission lines are the huge tower lines you see along the highway. The transmission lines are interconnected, so if one line fails, another can take over the load. We use electricity to perform many tasks. We use units called watts, kilowatts, and kilowatt hours to measure the electricity that we use. A watt is a measure of the electric power an appliance uses. Every appliance requires a certain number of watts to work correctly. Traditional light bulbs were rated by watts 60, 75, 100, as well as home appliances, such as a 1500-watt hairdryer. A kilowatt is 1000 watts. It is used to measure larger amounts of electricity. A kilowatt hour measures the amount of electricity used in 1 hour. Sometimes it's easier to understand these terms if you compare them to a car. A kilowatt is the rate of electric flow, or how much energy you are consuming at a specific instant. In a car, it would be similar to how fast you are driving at one instant. A kilowatt hour is a quantity or amount of energy, or how much you consumed over a period of time. A kilowatt hour is like the distance traveled in a car. We pay for the electricity we use in kilowatt hours. Our power company sends us a bill for the number of kilowatt hours we use every month.